Okay, so without further ado, I think I'll jump straight in. The time now is 5:05 and we want to make full use of our 1.5 hours. So welcome to the mid-year exam revision. This session is meant for Sec 3s. For those of you who have your upcoming exams and tests, hopefully this content that we cover today will be very helpful. Now, let me talk about what exactly we'll be covering. So I'll first start off with an overview to give you guys some tips on some revision techniques and stuff, followed by covering actual content. I'll be covering 2 chapters from chemistry, namely atomic structure and chemical bonding. And then I'll move on to physics. I'll be talking about kinematics as well as dynamics. Dynamics and forces is the same thing. All right. So that is your chapters that we'll be talking about. And as mentioned, towards the end of the session, there's actually a giveaway and you can win a set of curated notes. So why not give it a try, right? Okay. So like I said, if you're taking Chem Bio, don't be worried. I just want you to stay around when we're doing the Chem portion. You might just want to come back in later for the giveaway at the end. All right. If not, what are we actually going to be going through? We'll be talking about actual content that you need to learn. So I'll be going through key concepts like chemical bonding. What's the difference between your ionic, covalent, and metallic bonds? Furthermore, I'll also be looking at some commonly tested questions. Not saying that they will definitely come up for your test and stuff, but those are usually the questions that are more or less the same few usual suspects. So you want to make sure that you're able to do those questions as well. All right, so we will have both content as well as a bit of practice. Now, just a quick self-introduction. So this is me, I'm Daryl. So I mainly teach O-level chemistry and physics. I've been tutoring for quite a long time. I do both group tuition as well as crash courses. So right now I have like 10 to 11 classes a week. All right. So I'm guiding many students, a good majority. In fact, most of them are all Sec 4s. Just last year alone, if you're familiar with Overmark, we also do crash courses. So I conducted crash courses for over 200 plus students. All right. It was a joy, just to prepare them before their O-level. So I know I'm working with a Sec 3 crowd here. So in terms of the content and stuff, I'll try to lower the expectations a bit, but I still want you guys to learn what is really important about those topics. Now, I think what I would like to mention here as well, for those who are thinking, hey, I combine science, yeah, is this for pure science or combined science? Now, the topics that I've selected, they span across both combined and pure. So the content today will be relevant for everybody. Now, for segments that are only included in pure and not included in combined, I'll highlight them to you as well. Right? So some of the stuff you can like, okay, whatever, this one not my stuff. Okay. But if you're taking pure science, then you need to be listening very closely to everything that I say. All right. So now, stay till the end because there's a giveaway. Now, before I kickstart, I just wanted to share 3 key revision tips, right? So right now, late April, right? Your exam is anytime next week to the following week, right? You don't really have much time. So what I encourage you to do if you are very serious about making sure that your science is in good shape, okay, and you need to really recap on your content, honestly, thus far, right, you haven't learned many chapters yet. True, right? So for your physics and for your chem, maybe you have learned like, I don't know, 5 to 6 topics at most. So it's very realistic for you to do a quick 1-page summary per chapter. What I mean is that, okay, if you learn chemical bonding today, I want you to come up with chemical bonding, write everything you need to know on just a single A4 page, which means if you take both pure physics and pure chem, maybe you're only using up to 10 pages of A4. That is the summarized content. That is usually a very good way for you to accumulate what you already know so that you're able to recap on your key concepts efficiently. Now, there is no point just studying without doing practices. You do your TOS. If you have assessment books, you can do it too. If your school gives you worksheets, do those as well. It's very important for you to learn your content and apply it to actual questions. So which is why later on we'll be doing some actual questions itself after we learn the concepts. Lastly, this is one of the things that I hope you can start focusing on. Not only in Sec 4, then you'll be thinking about this, but I think from the very start, you want to build this good foundation, which is what I call your answering techniques. Sometimes you know your stuff, right? But sometimes the answer you write in the test, you realize you never ever get the mark, right? So what's the result of that? It's because you didn't get the answering technique, right? So today and later on, I'll be highlighting what are some key answering techniques you need to take note of. So you want to ensure that when you write down your answers in your structured questions, you actually write down the keywords that will get you to score well in exams. All right. So these are all things that I think would really help you if you want to accelerate your revision, doing summaries, doing actual practices, and getting your answering technique right. Because if you build your foundation in the right way and you progress on to Sec 4, I think you'll do a lot better. All right, now I'll jump straight in. So in terms of timing, right now is around 5:10. We'll be doing chemistry for the next 40 minutes or so. I can't give you an accurate estimate, but I think around 5:50. Then from there on, maybe another 30, 40 minutes of physics. And then the giveaway will be sometime between 6:20 to 6:30. So that is just a rough estimate because I don't want to rush through things. And if there are relevant questions, I want to address them as well. Okay, now let's get started with atomic structure. All right, now the soft copy of what you're seeing here, this notes, this is the actual curated notes itself in soft copy. For those of you who already have it, I highly encourage you to take out the booklet to revise alongside. For those of you without, please don't worry. You can just take down the important stuff. Now, let's take a look at what's really important in atomic structure. A good bulk of the chapter is surrounding proton, neutrons, and electrons. Take note for proton, neutrons, and electrons, what they are called is subatomic particles. Now, if you are wondering what exactly is subatomic particle, your atom is like this bubble, right? Is this ball? Inside the atom, there are smaller particles, which are your proton, neutrons, and electrons, which is why these three are called your subatomic particles. What you do need to know is firstly, proton is positively charged, which gives it a +1. Electron is a -1. Neutron is neutral, right? So if you want to, you can write that down. Neutron, just think of it as neutral. It has 0 charge. Now, what about the mass? The mass of proton and neutron is 1 and 1. It's very common, right, for students to think, okay, electron has no mass. Okay, no mass is not correct, guys. The keyword here is not that it doesn't have a mass, but it has negligible mass. Now, what does that mean? No mass means I literally have no mass at all. Negligible mass means I have a mass, but it's so small, right? I can neglect it. All right. So please remember for electrons, they have negligible mass. For the symbols, I think it's quite clear. Now, the location, this is a very important thing you want to be looking out for. You can put an asterisk or you can flip to your notes and make sure you're aware of this. Your protons and neutrons are found in the nucleus. Meanwhile, your electrons are found on the electron shells. Now, why is this important? I'll quickly browse through the part on electronic configuration, okay? So your electrons, hopefully by now, you know that the arrangement is 288. Now, what exactly is 288? 288 means 2 refers to the maximum amount of electrons it can hold on the first shell. Second shell, it can hold a maximum of 8. Third shell, it can hold a maximum of 8. To give you a very quick example, chlorine has 17 electrons. So how many electron shells will it have? In the first shell, it will have 2. The second shell, it will have the full 8. How many left? I have 17 in total, right? 2, 8, 7, right? So when I say chlorine's electronic configuration, I would say is 2, 8, 7. Because the 17 electrons has been distributed. There's 2 on the first, there's 8 on the second shell, and there's 7 on the outermost shell, the third shell. So when we talk about chlorine, it's 287. We'll come to why this is important later on. Now, back to this part about the nucleus. Yeah. So why is this part on knowing the location of protons and neutrons important? It's because if you move over to the numbers here, right? So in your periodic table, you'll see plenty of numbers, right? So for example, hypothetically, if you're looking at magnesium, it is 24 and 12. Now, 24 refers to the mass number. It implies the total number of protons plus neutrons. Now, why is that the case? Why don't we add electrons? Remember earlier, what did we say about electrons? Electrons have negligible mass, which means the mass is not important. So we don't account for the mass of electron. Meanwhile, for protons and neutrons, they each have a mass of 1 unit, which is why when we talk about mass number, we simply add protons plus neutrons. On top of that, what I want you to know is that mass number is not the only way for us to talk about this 24. It can also be termed as nucleon number. What is nucleon number again? Remember, nucleon, what's the base word it comes from? is nucleus, right? Can you see nucleon, nucleus? So my question to you is, what's inside the nucleus? We go back up, take a quick look. Your protons and neutrons are inside your nucleus. In other words, when we say mass number, or if we say nucleon number, is referring to the same thing. It's talking about the protons plus the neutrons. Is that clear? Nucleon number, mass number is effectively the same thing, because whatever's in your nucleus is your proton and neutron. Whatever gives you your mass is your proton plus neutron as well. Okay, Samuel has a good question. Does the subatomic particle relative atomic mass have any units? No, it does not have a unit, but I will not be addressing the why today because that falls under mole concept. For those of you who are interested to find out more about Samuel's question, you can go and look at what we call your relative atomic mass, AR. It is under your mole concept chapter. All right, but today I'm not going there, so I don't want to confuse the rest too. Now, the second digit at the bottom is also very important. We see this 12 here. This 12 is your proton number. It tells you your number of protons. Now, what do you realize about the top and the bottom number? The top is proton plus neutron. The bottom is proton. So, common sense question, how do I find number of neutrons? 24 minus 12. So I have 12 protons and 12 neutrons, giving me a total mass of 24. Quick question. Give you another one to try. Okay, so let's say my particle is sodium. If you look for sodium in your periodic table, it is 23 and 11. The 11 is what again? Is referring to number of proton, correct? 11 is number of proton. 23 is proton plus neutron. So how many protons do I have? 11, right? And how many neutrons do I have? You simply take 23 minus 11, that gives you 12 neutrons. So if you are ever required to find number of neutrons, you just need to remember you take the bigger number, subtract the smaller number. Okay, I'll talk about isotopes later on, so don't worry about that. Okay, take note, proton number and atomic number is the same thing. Now, something very important about this digit of 12, the smaller number, is that this gives you your protons, but your number of proton is equal to your number of electrons as well. Which means if my magnesium have 12 protons, I would have 12 electrons. So you can take a look at this part. Number of protons equals to number of electrons. Meaning magnesium has 12 protons and 12 electrons. Which means the electronic configuration of magnesium is... Think about it. I give you all 10 seconds. 12 electrons. How many can I hold on my first shell, second shell, third shell? What would the electronic configuration be? 2, 8, 2. Make sense? Right? In total, there are 12 electrons. 2 on the first shell, 8 on the second shell. I still have 2 more, right? So the 2 more, I'll simply put it on the third shell. So magnesium's electronic configuration is 282. So far, what have we covered? We talked about proton, neutrons, electrons, where they are found, their mass, as well as their charge. We learned the electronic configuration is 288. Anything more, you have to go to the next shell. Do you have a fourth shell? Of course. All right. So you can do the fourth shell as well. Then we talk about the importance in understanding the numbers here, and specifically, how do we calculate number of neutrons? Now, if you understood everything so far, you will have a much easier time understanding the next part on ions. Now, here we have 2 types of ions. We have your positive ion and we have your negative ion. Now, for positive ion, it's called a cation. For negative ion, it's called an anion. Then you'll be like, they're hard, how to memorize this, okay? Simple. You look at the way cation is spelled. And I also want you to look at the way an ion is spelled. Do you see the last part is just an ion? Correct? So it's the same, okay? Now, what about the portion here? T, right? Can you see this T? Is like a plus sign. You know, T and plus, it's like the same thing, right? So positive, right? N is what? N it's negative, right? So N ion is negatively charged. Cation has the plus sign, it's positively charged. So that way you do a simple association. You don't really have to hardcore memorize it anymore. Okay, so cation and anions. Now, who will form cations? For those of you with your periodic table, I want you to actually open up your periodic table now. We're gonna label some stuff on your periodic table. Okay, let me open up a periodic table on my end too. Okay, so let's take a look at the numbers. In case you're not aware, this is 1, 2, group 3, group 4, group 5, group 6, group 7, group 8. Now, this is the group number. Now, how does it work exactly? Let's use sodium as our example again. Sodium has 11 protons, 11 electrons as well. So the electronic configuration of sodium is 2, 8, 1. Potassium's electronic configuration is 2, 8, 8, 1. Lithium's electronic configuration is 2, 1. Okay, if you're wondering why I'm just using this. The proton equals to electron. I figure out what's the electronic configuration. Now, why are they all placed in group 1? Can you see here the common trend? They all have 1 electron on the valence shell. Valence shell is referring to the outermost shell, right? So the outermost shell, there's only 1 electron. That's why they are placed in group 1. Now, what you need to know is this. For an ion, what is hoping to achieve instead of 281? Can see here, sodium is 281, right? It doesn't want to be 281. It wants to be 28. Why? This is what we call your stable electronic configuration. Meaning, if I only have 1 electron on my outermost shell, that's like a bit like not sure, like the one that like there's 1 extra, right? So what do? You cut away that. You make sure that you give away the electron. So nice, right? It's like you have 2, 8, and each shell is fully filled. So now sodium is like, wow, I'm happy, right? From 281, now I very clean cut, I become 28. And in that process, because it gave away an electron, there will now be more protons than electrons, right? Previously, how many protons, how many electrons? Previously, there were 11 protons, 11 electrons. But when I gave away 1 electron, I have 11 protons and only 10 electrons. I gave away 1 electron. So if I have more protons than electron, my charge becomes plus. So normally when we say when an atom loses electron, more protons than electron, it becomes positively charged. Okay, so the logic here is simple. 281, I don't want that. I want to be stable. So I want to become 28. In the process, I'll give away an electron. That makes me have more protons than electron. I'll be positively charged. Meanwhile, for chlorine it's 287. It's like, wow, a little bit annoying, right? It's like, wow, almost 8, but it's like 287. So what does it do? It will choose to gain an electron to become 288. If I gain an electron, I will become negatively charged, right? Because electrons negatively charged, which is why you see the charges here. Okay, so this is what we call formation of your cation and anion. Did I gain or lose electron? Why did I gain or lose? Is so that I can gain a stable electronic configuration. I always want my outermost shell to be fully filled. Now, going back to the periodic table, what do I want you to write down? Okay, you can write this down alongside me. Group 1, the ions they form is usually charge of +1, +2, +3. Now let's address this first. Why +1, +2, +3? Can you see that for metals in group 1, they always have 1 electron on the outermost shell? Meaning, if they want to form an ion, they would tend to give away an electron. They want to remove that 1 electron on the outermost. When they do that, they will become positively charged with a charge of +1. For metals in group 2, they will have 2 electrons on the outermost shell, which means when they try to go and try to form an ion and stuff, what will happen is that they will give away 2 electrons. which is why you can see that group 1's charge is +1, group 2 is +2, group 3 is +3. Group 4 is a bit more unique. It can be +4, -4. Now let's do group 7. Okay, group 7, what would the charge be? Just now chlorine was what? Chlorine was 287, right? It gained an electron. So the charge became minus. So group 7 is -1. Group 6 is 6 electrons on the outermost. I will need to gain 2 electrons. Group 5, I have 5 electrons. I need to gain 3 electrons. So -3. So in other words, what we are writing up here is the charges of the ions it tend to form. So you can see that for metals in group 1, 2, and group 3, they tend to form positively charged cations. Meanwhile, for non-metals, they tend to form anions. Group 8 would not have any charge because they already have a stable electronic configuration. Okay, now in terms of the +4 and -4, this one I can't go too in-depth, but you are right to say that they are usually covalently bonded, but that doesn't mean it cannot be ionically bonded too. All right, but I'll keep it as group 4 is a little bit more vague for now. Okay, don't want to overwhelm you guys too much. But mainly what you'll be tested on is usually group 1, group 2, and group 5 to group 7, and sometimes even group 8. The schools do not really torture you with group 3 and group 4 as much. Not until you learn your set 4 topics at least. All right, so at the moment now, I hope it's clear the difference between your cation and your anions. Now, to finish up this chapter, all we are left to discuss is this thing called isotopes. Very likely your school will be testing you on the definition of isotopes. So please nail this down. Isotopes are atoms of the same element with the same number of protons, but different number of neutrons. Now, I always say this story, right? That if you take a look at your periodic table, there is one very interesting element, which is your chlorine. Do you notice everything else is a whole number? It's 27, 28, 31, 32. Then this troublemaker, chlorine is 35.5. That's like, what the hell, right? So if you look at the numbers here, 17 is what? 17 protons, right? 35.5. Huh? Does it mean it has half a neutron? Right? Because we said that if we take 35.5 minus 17, we can get number of neutrons. So how does that work? Now, what exactly is an isotope? Isotope means they are both chlorine. So there is chlorine 35. There's also chlorine 37. Both of them have the same number of protons. You can see 17 and 17. But their mass is different. How so? Chlorine 35 is the skinnier version of chlorine. It only contains 18 neutrons. Meanwhile, for chlorine 37, it is the fatter version of chlorine. It has 20 neutrons. Now, how do we come up with the term 35.5? Because, you know, for example, if you go, I know you all don't play Pokemon Go, but maybe your parents do, right? So, you know, when you go out there and you try to catch a Pokemon, there's the common version and there's the rare version with higher stats, for example, right? So you need to know when you go out there and you try and grab a chlorine atom, right, from the atmosphere, you just grab one. 75% of the time, you're going to be catching a chlorine 35. Then sometimes you grab, right, and you're lucky, you caught the rare version of it, you'll get chlorine 37. Okay, so chlorine 35 and chlorine 37 exist in different percentage. 75% of the time is 35, 25% of the time is 37. Therefore, via calculation, if you find the average mass of chlorine by taking 35 times 75% plus 37 times 25%, the average mass of chlorine is 35.5. That's why in your periodic table, you see 35.5. It doesn't mean that there was half a neutron, right? Because what the 35.5 represents is the average mass. Okay, if you have your textbook with you, you might want to write that down. Isotopes means that there are different versions of the same element, chlorine 35, chlorine 37. The 35.5 is simply the average mass after I do my calculation. So this is average mass. That's how I get 35.5. If the elements are different, they are not considered isotopes. They are just different elements. Elements only apply if they are both chlorine, but one is chlorine 35 and one is chlorine 37. That's how it works. Okay. And one last thing that I want you to know here is that isotopes, they will have the same chemical properties. This is because both are chlorine, right? Both have 287 as their electronic configuration. So they'll undergo the same chemical reactions. But isotopes, they will have different physical properties. Why? You can see very clearly it's 18 versus 20, right? So they actually have different number of neutrons. So different number of neutrons means my mass is different, right? So things like your density, other physical properties would differ. So questions will ask you like what define isotopes, right? Then you must tell them, oh, okay, isotopes are atoms of the same element, same number of protons, different number of neutrons. They might even go one step further to ask you about the average mass, or they might ask you about the chemical and physical properties. So these are the things that you need to look out for. Okay, and with that, that is pretty much it for isotopes. Okay, and we're actually done with atomic structure. But as usual, there's no point learning the content without doing actual questions. So for each question, I'll give you around 30 seconds to a minute to try. I'll go through immediately after. All right, so these are actual 10-year series questions. So let's study them together and see what's the correct approach towards solving it. Okay, I'll just give you 30 seconds to try question 4. For those with burning questions about atomic structure, just type it in the chat. We just went through atomic structure. Don't need to tell me your answer. Okay, if you know your answer, good, then you can double check if it's correct later. Stable electronic configuration and stable octet structure is referring to the same thing. So Ryan, that's fine. It just means that your outer shell is fully filled. Okay, let's go through question 4. Now, when I first see this question, right, something that I might be afraid of if I'm like your teacher is that, wah, jialat, you all know what is nucleon number or not? Remember what is nucleon? What's the base word of nucleon? Nucleus, right? And what's in your nucleus? It's your protons plus your neutrons. In other words, if I have proton number here, I got my nucleon number as we have discussed, right? Nucleon, nucleus, proton and neutrons inside your nucleus. What is your number of neutrons? You simply have to take 39 minus 19. So W is 20 neutrons. Okay, next, let's move on to the next row. K plus. What is this plus? Meaning we are dealing with a cation, right? Do you still remember? Positively charged cation, the plus sign, correct? So let's take a look at the number of electrons for your, number of protons for your K. Okay, K has 19 protons. So by right, how many electrons should it have? By right, it should have 19 electrons. Because proton and electron is the same. But take note, it will not be 19. Why? Because it's an ion. Ion implies that there was a movement of electrons. So for K, it used to be 19 electrons, 2, 8, 8, 1. Agree? Then, when it turned into an ion, what did it do? It became 2, 8, 8, right? Get rid of that one that's annoying, right? Kick it away. So my next one is fully filled. So how many electrons now? Only 18 electrons. So X should not be 19. A lot of people will choose 19, but I need you to know that ion means there was a movement of electron. Therefore, X is 18. I hope it makes sense. So here, 18, because I gave away an electron. Using a similar logic, here S is an ion because it's negatively charged, meaning it has gained electron. In the past, I started with 16 electrons, right? So Z was a 286. It became a 288. it gained 2 electrons. So how many electrons does S have? S will have 18. So Z is 18 as well. Lastly, how do we find Y? You simply need to add the proton plus neutron. 16 plus 16, 32. Therefore, answer here should be C. Okay, that's all. So I'll move on to the next question. Question 5. Let's take a look. Okay, I'll upload the video ASAP, maybe over the next 2 days and stuff. For the discussion in the chat, yes, stable electronic configuration would be a bit better because it applies to both your duplex and octet structure. But usually when they test, it is usually octet structure. So generally at Sec 3, I think it's still fine to use either. But I personally prefer stable electronic configuration as well. Okay, for question 5, I'm sorry, I might not have the time for you to try out fully because I want to do this question alongside you. Now, this is actually an exam technique that I teach my students as well. So take note of how I approach this question. Normally, when I do a question like this, okay, what I tend to do is I'll write out what I call your P and E, your proton, neutrons, and electrons. So for carbon itself, you just write down 14 and 6. Nitrogen is 15 and 7. Oxygen is 16 and 8. And F is 17 and 9. So I just write it out in this like table format or whatever you call it, all right? But what's important is I would try to write down the exact number of protons, neutrons, and electrons. For carbon itself, we see this 6 at the bottom. That tells me there's 6 protons and 6 electrons. How do I find neutrons? I take the bigger number minus the smaller number. Remember, because the bigger number is protons plus neutrons. 6 is 6 proton. So if I do a simple subtraction, I can find that I have 8 neutrons. I'll do the same for the remaining. 7, 15 minus 8, 15 minus 7 is 8. 8 protons means 8 electrons. 16 minus 8, 8. 9 protons means 9 electrons. 17 minus 9 is also 8. So which of the statement is true? B is true because you can see here clearly, they all have the same number of neutrons. So what I'll advise in the future is that if you come across an atomic structure question, a very powerful exam technique you can do is to break down each individual atom in terms of its P and E, the proton, neutrons, and electrons. Then answering the question will be a lot faster. Okay, so one final question for atomic structure before we move on to chem bonding. Okay, question 2 here. What's the definition of an isotope? Okay, do you still remember? Isotopes are atoms of the same element with same number of protons, but different number of neutrons. So I think this is very important for us to all take note. All right, this is the correct definition. All right, if you're unclear still, please go and revise this. Isotopes, very high chance of coming out. Okay, that's all. All right, so make sure you're aware of that. If not, I'm going to move on already. Let's talk about chemical bonding, which is a lot of a bigger topic. Okay, I think this is the big one. I think many of you here will need help. So let's talk about this chapter. All right, so first we want to take a look at element, compounds, and mixtures. What's the difference between them? Now, very quickly, I need you to know that when we are talking about elements, we are usually describing things that are purely by itself. For example, H2, N2, O2, these are all considered elements because it's purely hydrogen, purely nitrogen, purely oxygen. You can also think of elements that exist naturally as, like, for example, silver, all right, or copper metal. You see all of this, they are not bonded to anything else. We call this elements. Compounds, on the other hand, refers to things like H2O, CO2, and even ionic compounds that you'll learn later, like NaCl. Meanwhile, mixtures means that it is things that are being thrown together. The key difference is this. Compounds are chemically combined, which means they underwent a reaction and it formed a compound. Meanwhile, for mixture, right, it's like rojak like that. You just throw things in, right? You just physically mix them. There wasn't actually a chemical reaction. So if you want to think of chemically combined, just remember it means that there was a chemical reaction with reactants and products. Physically combined means I just mix them, right? So there wasn't any chemical reaction. Here we see a couple of differences between compounds and mixtures. Just remember that if my compound is chemically combined, if I want to separate it, I need to separate it using chemical methods. A lot of these methods, you're going to learn them next time when you finish your syllabus. For now, just know that they are separated. They were formed using chemical reaction, which means they should be separated using chemical reactions as well. Meanwhile, for mixtures, they are physically combined, which means when you separate them, you'll use physical separation techniques. Those that you have learned from your filtration all the way to your chromatography, just understand that those are all physical separation methods. Now, something that I want you to take down is this. If your school asks you, hey, how do I know if this substance is pure? Okay, you just need to know there's only one correct answer. If it's pure, it will melt and boil at a fixed temperature. Pure water will always freeze at 0 degrees Celsius. It will always boil at 100 degrees Celsius. If you're dealing with something that's impure, it will melt and boil over what we call a range of temperature. This is a really important part. All right, some of your schools might not specifically highlight this, so I just wanted to bring it up so that you guys are aware. Okay, I'll just give you 30 seconds to write this down somewhere. Very important fact. Take note, when we say mixture, it means it is impure. Because something that is pure meaning pure water. There's only water. There is no like impurities inside. So mixture implies that it's impure already. Okay, and for those of you who are done copying, I zoom out a bit. I just want you all to look at the boxes at the bottom. So quite common that your school will probably give you some boxes and they ask you, hey, which one, identify which one is element, compound, which one is a mixture. All right. So you just need to understand that when we say compound, it means that there are two things combined. Meanwhile, when we say mixture, mixture just means there's various things put together. All right. So element can be a single dot. It can even be a 2 dot. All right. You can even have a mixture of compounds and a mixture of elements. All right. So these are the few that you want to look out for. Okay, now I want to move on to the highlight for today, which is your ionic covalent metallic bonds. Now, I need you all to realize that when we are doing this chapter, all right, there is a slight difference between pure and combined. I will go through ionic bonds first and covalent bonds. Both are within the combined syllabus. There are something else later that is not within. I'll highlight it accordingly. Now, ionic bond can look very complicated if you make it very complicated. But I'm going to simplify it for you. Just remember this. When do we form ionic bonds? We form ionic bonds if it's between a metal and non-metal. Full stop. Remember, metal, non-metal, ionic bond. Later on, you'll learn covalent bond is what? Non-metal and non-metal. That is the most important part. Now, why ionic bond? Ionic bond came from the word ion, right? So ionic bond naturally forms between a cation and an anion. This is why I always teach atomic structure and chemical bonding together, right? Because you learned cation and anion earlier. Now you learn that when a cation interacts with an anion, it forms an ionic bond. What exactly is your ionic bond? It is the electrostatic force of attraction between your oppositely charged ions. I'm sure you heard of the term opposites attract, right? So one is plus, one is minus, they attract. That attraction, that force of attraction is your ionic bond. That's all. Okay, so in summary, what is an ionic bond? It forms between metal and non-metal. It is between a cation and an anion. Unlike attract, so opposites attract, that attraction is called electrostatic force of attraction. Therefore, ionic bond is an electrostatic force of attraction between your oppositely charged ions. Okay, so we use electrostatic force when it's between a plus and a minus. So electrostatic force are specifically used for plus and minus. We'll be using it again later in metallic bond. Okay, I got some good questions in the chat, but I'll address that along the way. So that is your ionic bond. Take note, this structure here is called your giant ionic lattice structure. Within the structure exists many ionic bonds. Okay, right? So if the school is asking you, describe in terms of structure and bonding, the structure is giant ionic lattice structure. So this one here is structure. Bonding is talking about the strong electrostatic force of attraction between your oppositely charged ions. Okay, so your school will always ask you one, in terms of structure and bonding, explain why, blah, 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 blah. Okay, what would they ask you to explain? Just take note, there's 6 properties here, but I'm only going to go through the first 3 because these are the ones that are usually tested. This is what I need you to know. Half the time, they'll ask you to explain why ionic compounds have high melting boiling point. This is where I talked about answering technique earlier. Remember how to score in an exam. What you need to know is that they have high melting boiling point. How you score the full marks in the exam is firstly, you talk about the structure. Giant ionic lattice structure. Then you talk about the bonding, held together by strong electrostatic force of attraction between oppositely charged ions. Then a lot of students, they just stop here. It's like, wow, shook. My tutor tell me, right, okay, just write structure plus bonding, right? Then done. Cannot. It's about melting boiling point, right? So you have to talk about, okay, if it's very strong, right, requires large amount of heat energy to overcome. Therefore, melting boiling point is high. So whatever I've highlighted here is what we call the keywords and the important answering technique. At its core, I need you to remember we always discuss in terms of the structure, and then we mention the bonding. Then you relate it back to the high melting boiling point by talking about, A, I require a large amount of heat energy to overcome. Okay, then for solubility, I just need you to know that ionic compounds are usually soluble in water. Okay, that's all. The rest of the explanations are not important. Not up to you are like Sec 4 level, then we can talk about it. Okay, if you want, okay, for Ryan's question, right, how do you explain why magnesium oxide is insoluble? Technically, you don't need to explain it, but if you need to explain it, right, and your school is somehow testing you on it, it's because of the water molecules and the hydrogen bonds form. But honestly, that is out of syllabus already, so I usually don't address it. So what you need to know is that ionic compounds are soluble in water. For those of you who are struggling to memorize this, right, do you all know what is NaCl in real life? NaCl is literally the salt that you throw when you use when you're cooking. Does salt dissolve in water? Of course, right? You can visualize that, right? So you just need to remember, okay, NaCl ionic, salt dissolve in water. Okay, ionic compounds are soluble in water. Now, what else would they test you on? One very important part is the electrical conductivity. Melting boiling point and electrical conductivity are the 2 most commonly tested ones. Now, what about electrical conductivity that you need to know? When in molten and aqueous state, take note, ions are free to move. Therefore, ionic compounds can conduct electricity. But ionic compounds do not conduct electricity in solid state. Okay, because in molten and aqueous, the ions are no longer held in their fixed position. So they can move. If they can move, they can conduct electricity. But in solid state, they are stuck in their fixed position. So they are not able to conduct electricity. Okay, so 3 conclusions are, and then I'm moving on. High melting boiling point, understand how to explain it with keywords, know that it's soluble, and know that it can only conduct electricity in molten and aqueous state. That's all you need to know for ionic compounds. Now, let me move on to your covalent. Covalent compounds, earlier ionic was what? Metal, non-metal, right? Covalence between non-metal and non-metal. How they bond is via the sharing of their electrons. If you look at chlorine, they only share 1 pair, such that both sides will get 8. Look at water already have 4 here, so it shared 1 pair each with the hydrogen. At the end of the day, oxygen will have 8 on the outermost as well. So you just need to make sure that when you share, everybody is satisfied. You put in hydrogen give 1, oxygen give 1. At the end of the day, everybody have a fully filled shell. Now, moving on to the more important part on the structure and the bonding. This is the part, right, where a lot of people die. Okay, This part, you need to listen extra careful. If not, you confirm make the mistake. Okay, now, what a lot of us will write is we'll write that, okay, simple molecular structure. We know low melting boiling point. Then you know what you'll say? You'll say, oh, covalent bonds are weak, right? Low melting boiling point, covalent bonds are weak. Because you think that, oh, ionic bond very strong, right? High melting boiling point, which means low melting boiling point means covalent bonds are weak. That is a misconception. That is not true, guys. Between ionic bond and covalent bond, both are freaking strong. Get that in your head right now. Ionic bond is strong, covalent bond is also strong. Okay, then the question you will definitely have is, if covalent bond is strong, then why does it have a low melting boiling point, right? This is because when we are doing simple molecular structure, what we are breaking down is not the covalent bond. What we are breaking down is the weak intermolecular forces of attraction. Now, let me elaborate quickly. This here is a molecule. This is a molecule. This is also a molecule, right? Molecule means this is an ammonia molecule, right? NH3. Now, remember, you see this part that I'm highlighting here? This is the what? This is the actual covalent bond. This covalent bond is super duper strong. An analogy that I can give you here is just imagine this NH3, right, is like the mother and the three kids, right? The mother loves the three kids. I'm sure your mother loves you, right? So the bond here, that covalent bond that you share is super strong, right? Your parents don't give you pocket money, GG, right? You love them, right? Okay, now just, you get what I mean, okay? Within the family itself, the bond is super strong. But now think about it. Between this family, family 1 and family 2, they are neighbors. Is the bond between the neighbors as strong? It's not, right? I mean, it could be like if your neighbor has like a cute dog or something, maybe you would say hi auntie, hi uncle, right? Whatever. But like honestly, if you ask me, I don't know my neighbor's name. I call them auntie, uncle, right? One day if my neighbor move away, I will be maybe sad for a bit, but I won't like be super sad. So what I need you to know is that the covalent bond within the family is super strong. But the bonding between one molecule and the other, this bonding here, the dotted lines that I'm drawing, this is very weak. This is the weak intermolecular force of attraction. Intermolecular means between molecules. So all I'm trying to tell you is this. Within your molecule, covalent bonds, they are super strong. But between one molecule and another molecule, that attraction is very weak. That attraction is very easy to overcome. Therefore, simple molecular structures have very low melting boiling points. Yes, this is the curated notes. Okay, the one that you're seeing here, this is just part of it. Are we clear on this? This is super important. Okay, so is covalent bond weak? No, covalent bond is as strong as your ionic bond. What is weak is the weak intermolecular force of attraction between your molecules. From one family to the next neighbor, that bond is weak. Within the family is strong. So please do not mistaken it. And once again, if we quickly move on to the next portion here on the low melting boiling point, remember the answering technique. It is about the structure, so simple molecular structure, and the bonding, weak intermolecular forces of attraction. Therefore, you say little heat energy is needed to overcome. So low melting boiling point. Take note that the covalent compounds are largely insoluble in water and they do not conduct electricity. Are we clear? Okay, so giant ionic lattice, simple molecular. Okay, what I'm about to discuss in the next 5 minutes, this is not relevant for combined chem anymore. Okay, so for those of you who are taking combined, you can take a chill pill and sit back and relax. For my pure students, please listen up. All right. Covalent bonds, there are two kinds. There's the simple molecular and there's the giant molecular. For giant molecular, there's exactly 3 compounds that you need to learn: diamond, silicon dioxide, and graphite. For diamond itself, I think this one you all know what it is. Keyword here is tetrahedral structure. It means that each carbon is bonded to 4 other carbons. Okay, diamond, as you know, is super strong, very high melting boiling point. All right. Silicon dioxide, all right, is SiO2. All right, same thing. It is a giant covalent structure. Graphite is the one that's most interesting. Okay, graphite is also made of carbon, but instead of 1 bonded to 3, each carbon atom in your graphite is bonded to 3 other carbons. forming these hexagonal layers. Take note, between one layer and another layer, the forces of attraction are very weak. This is the same thing earlier when we were talking about intermolecular forces of attraction. Okay, so between layers, the graphite can easily slide past one another, which makes it a very good lubricant. But you also need to know that graphite, because of the way it is bonded, the one carbon is bonded to 3 carbons, meaning there's a 4th electron that's free to run around. This 4th electron is actually able to conduct electricity for graphite. So far, what could conduct electricity? Ionic compounds in molten and aqueous. Graphite is also able to conduct electricity. Okay, so these are your 3 giant molecular structure. Very quickly here, the properties are largely the same, but instead of low melting boiling point, your giant covalent structures actually have very high melting boiling points. The reason for that is because what we are actually breaking down is the covalent bonds itself. Get the slight difference? Simple molecular is intermolecular forces of attraction. For giant molecular structure, what we are breaking down is the covalent bonds itself. They are still insoluble in water, and they generally do not conduct electricity except for graphite. Okay, and that brings me to the last one on metallic bonding. So metallic bonding, how you will call it, is that you will say that there's a lattice of metal cations surrounded by a sea of delocalized electrons. So that's the way it is structured. What do you need to know about metallic structure? Actually, this one is quite common sense. It has high melting boiling point. Now, the part that I think you might be unfamiliar with is the bonding and the structure. So previously, when we were doing ionic bond, it was between cation and anion, plus and minus. So we use the term electrostatic force of attraction. In metals, we use the same thing. Why? It's because it's a lattice of metal cations and a sea of negatively charged electrons. So the term here, strong electrostatic force of attraction, you can use it for both ionic and metallic because it's between plus and minus. Okay? And lastly, you need to know that metals obviously can conduct electricity because your delocalized electrons here act as mobile charge carriers. Mobile charge carrier is a keyword. Okay, generally in the curated notes, for those of you who bought it, you will notice that the keywords are all bolded for you already. So whatever that's bolded is a keyword that you should include in your answer. Okay, now finally moving on, there are some commonly tested questions as well in the notes. I'm just going to show you one here. So this is what I need you to know. If you're dealing with ionic bonds and they're asking you which one is stronger, right? Think about it. 2 plus, 2 minus. This is calcium oxide. Sodium chloride is plus and minus. Using basic common sense, which one is a stronger ionic bond? The 2 plus and the 2 minus, right? Because 2 plus and 2 minus, the electrostatic force of attraction will be stronger. So if you look at the melting boiling point, you see calcium oxide is much higher than sodium chloride. This is because the ionic bond in calcium oxide is stronger because it's plus 2 minus 2 versus plus 1 minus 1. So these are some of the questions that are commonly tested. You can find them at the back of the chapter in your curated notes too. Okay, so I think this is one of those that I like to highlight. Now, for this, let's try another 3 questions real quick. Then I'll move on to physics already. Okay, so first question, let's take a look at this. Okay, I'll give you all maybe 20 seconds to browse through and I'll explain what's the correct answer. You use the word dissociation when an ionic compound dissociates into its ions, but honestly, you use dissociation more often when you are dealing with acid and alkalines. So another chapter. Okay, I'm answering Ryan's question. Okay, for question 1 that we see here, can you all tell me whether this is ionic or covalent? How do you all know? What you want to do is to quickly go over to the periodic table, look for your arsenic, look at your bromine. Are they metals or non-metals? They are non-metal, right? So non-metal means covalent bond. The ionic bond question is relevant for both combined and pure, okay, because it's ionic bond. So I need you all to know when you all see this compound, you need to recognize here we're dealing with a covalent compound. Is this a simple molecular compound or a giant covalent? Simple molecular, right? Giant covalent, there's only three: diamond, graphite, and silicon dioxide. Therefore, what do we need to know about the melting boiling point? Is it high or low? Remember, for simple molecular structure, it has low melting boiling point. For those of you who need a little bit of revision, remember earlier we discussed this concept before. Between the neighbors is very weak, right? Weak intermolecular force, low melting boiling point. So you're choosing things that have low melting boiling point. Do covalent compounds conduct electricity? It does not. So answer here is just A. So when we're discussing chemical bonding, it's very important for you to be looking and studying your different properties of your bonds. Okay, there are 4 for pure and there's 2 for combined. Ionic, simple ionic bond, covalent bond, there's 2 types, and there's 1 metallic bond. Okay, question 6. Aluminium oxide versus calcium oxide. This is aluminium oxide. Because aluminium is in group 3, right? The ion form is usually 3+. O is in group 6, so it's 2-. You all know what I mean, right? This one, earlier we learned this. Right? The ions charges. Then for calcium oxide, calcium is in group 2, oxygen is in group 6. So why is the melting point of aluminium oxide higher? We just learned this, right? Because calcium is 2+, smaller charge than aluminium. You get it? I'm talking about this, right? We mentioned the bigger the number, the stronger the ionic bond. Okay, so for question 6 here, answer should be C. Okay, now finally down to the last question. This one is very difficult. Okay, for this one, this is when you need to draw your dot and cross diagram. I'm just going to draw out A as a sample. So for F, you need to go back to your periodic table, but you realize that F's electronic configuration is 2,7. For hydrogen, it is 1. So for a compound, a molecule formed between hydrogen and fluorine, this is how it looks. Do you notice that there are some electrons in fluorine that are not involved in bonding? Right, so A cannot be the answer. Let's take a look at the correct answer. All right, CH4, how will we draw it out? This is C. There's 2 electrons on the inner shell, and then H. Would share a single covalent bond with C. So this is actually called methane. You'll notice that all the electrons are all involved in bonding for the outer shell. Hydrogen only has the 1, carbon has 4, and all 4 are involved in bonding. Okay, so answer here should be D. Okay, and with that, I come to the end of the portion for chemistry. So I hope that this part is clear, right? In terms of atomic structure and chem bonding. Chem bonding is one of those topics you probably need to revise the day before your exam. All right. So for my chem students, chem bio, you might want to stay till the end because there's a special segment later as well as a giveaway. You might just want to come back in around 25 minutes or so. All right. Then for the rest, let's push on for physics. But before that, let's take a quick 2-minute break. We'll resume at 6:05. So we're going to be going through kinematics as well as forces. Let's talk about what you do need to know about these 2 chapters. Okay. I think what's really important here is you need to understand the difference between what we call a scalar and a vector. Right. So we start off with that. Scalar means I only have magnitude. Vector means I have both magnitude and direction. The main thing is, does it have a specific direction? If it does, we are dealing with a vector. Okay. If it only has magnitude, that means I don't care about the direction. You go left or right, not my issue, right? It is a scalar. So you need to understand that when we're discussing distance and displacement, both of them are trying to measure length, right? Unit of movement in length. But the difference here is that for distance itself, it doesn't care about direction. But for displacement, we do care because displacement is a vector quantity. Meaning for displacement, you need to specify, am I moving forward or am I moving backwards? All right. And that's what brings us to the next part, which is distance gives me speed. I think we already know this, right? rate of change in distance per unit time is speed. But if you look at the definition for velocity, it's the change in displacement per unit time. All right, so the scalar goes to the scalar, the vector goes to the vector. Okay, so you need to be able to draw the link, all right, between distance and speed versus displacement and velocity. So one is a scalar set, one is a vector set. Now, what kind of questions will we get? All right. Another term that you need to be familiar with before we go into the question type is the term acceleration. Acceleration just means increase in speed. All right, to put it very simply. Think about when the car enters the highway, right? Highway, your speed limit goes up. So when you step on the accelerator, the car goes faster and faster. That is acceleration. All right. Just because I'm moving at a high speed doesn't necessarily mean I'm accelerating. Accelerating means I'm going faster. That is really important. So for a graph itself, you'll notice that one kind of graph that you can get is a displacement time graph. Now, displacement time graph is where you get displacement as your y-axis and time as your x-axis. Now, what you need to know here is this, gradient represents your velocity. Now, what do I mean? If you take a look for the first 2 seconds from 0 to 2 seconds, can you see this is a constant velocity? Since gradient represents velocity, it means that this portion here is constant velocity. Okay, this is a displacement time graph. Now, the other kind of graph that you're more likely to get is called the velocity time graph. Now, for velocity time graph, there are 2 things you need to know. If the y-axis is velocity and the x-axis is time, you want to know that your gradient here represents your acceleration. So I repeat again, you'll go back here. Can you see this is a constant gradient? We said constant velocity, right? Because this is a displacement time graph. But the gradient of a velocity time graph, the gradient gives you your acceleration. So here we say constant acceleration. Furthermore, what you need to know as well is that the area underneath your graph represents displacement. I want you to focus on this first portion at area x. Can you see area x, everything is in the positive range, it's above the x-axis? This means that any part of area x is about the car moving in the forward direction. Meanwhile, in area y, if it's below the x-axis, it means that it's moving in the reverse direction. AKA, the car went like that. This is x, and then it U-turn and go back with y. If you go and calculate the area of x and the area of y, you can find the values respectively. So these are the 2 analyses that you need to be able to make for velocity time graph. Gradient representing acceleration and area underneath the graph representing displacement. Very important question. If I want to find the total distance, how much is it? Distance, it would be x plus y. Correct? Because do we care about the direction? We don't, right? So for distance, I merely care about how far did I travel. Okay, I go by x, then I go y. So I take x plus y to get my total distance. But if I'm hoping to calculate the displacement, it would be x minus y. This region here that I've highlighted is your displacement. Why do we do that? Because in displacement, we care about the direction, right? So at the end of the day, this is where I started versus where I ended. That is displacement. So you need to know that distance and displacement, they are not necessarily the same, assuming there's a change in direction. So distance, we simply add up as much length traveled as we needed. Displacement, you need to think about the direction. That is very important. So this is applicable across for both pure and combined. Velocity time graph is the one that will be tested the most. I'll be showing you all some questions right after this. But before I move on to that, okay, one final thing I'd like to address for kinematics is terminal velocity. For those of you who are tested on this, would be for pure. For combined, there is no terminal velocity. So if you're taking pure, you low-key need to be super aware. The answering technique here is super important. Like I told you, what are the keywords you need to write in your exam? Firstly, for terminal velocity is a situation whereby your speed doesn't increase. Terminal means it stops there. So the speed maintains. How do we achieve terminal velocity? When we travel faster, we experience more air resistance. Now, a very simple analogy is this. When you're at the bus stop and you're running for your bus, okay? Before you see the bus when you're walking, right? Not much like, okay lah, I just walk normally, right? But once you see the bus and you start sprinting, right? Do you feel like there's more wind gushing in your face, right? So when you sprint, you can feel the wind blowing in your face. That is air resistance. So what I'm trying to say here is that when you increase your speed, air resistance will increase. Okay, so first thing you need to know is that air resistance increases when velocity increases. There will be a point where air resistance is equals to the weight of the object. Now, what does that mean? For an object in free fall, it will have a downward weight, pulling it down. This is your gravity at work. It's pulling you down. But you need to know that as you're falling, it's not just the gravity. There's also air resistance. Air resistance is slowing you down. All right. So a combination of the two, weight going down, air resistance going up. As you fall faster and faster, your air resistance increase. It will increase to a point where your air resistance equal to the weight. When that happens, your resultant force is zero because they cancel each other out. There will be no acceleration. If no acceleration, you go at constant velocity. That is known as terminal velocity. Okay. Now, this is how we explain terminal velocity. Basically, everything that I highlighted here are keywords that you must include in your explanation. Now, for a very important pro tip, this question type is very common. If you don't listen here, there's no way you're going to get it right. Okay, listen carefully. If objects, they have the exact same shape and the same size, the only thing that's different is the mass. Take note, they will have the same initial acceleration. Now, what do I mean when I say same initial acceleration? Initial acceleration here is referring to the value of g. The value of g is constant on Earth. Gravity is always the same. It is always a value of 10. So whether your object is larger mass or smaller mass, gravity acts the same. Doesn't really matter. So your initial acceleration will be the same because gravity is the same. But the heavier object will have higher terminal velocity. Why? Because if your weight is bigger, your air resistance to counter it needs to be bigger as well. So your object will undergo free fall for a longer period of time. So a heavier object will be able to achieve a higher terminal velocity, but both objects would start off with the same initial acceleration. Okay, I want to explain this further, but I don't have time, guys. Okay, but if anything, please write this down. Take note, two objects, same size, different mass, same initial acceleration, cause same gravity. Heavier object will have higher terminal velocity due to its greater weight. All right. For those of you with the curated notes, you'll know that there's many pro tips put throughout. These are where your most commonly tested questions tend to appear. All right. So of course you have your work examples later on, but I'm just telling you that the pro tip is there because it's a pro tip, guys. So please go and take note. Okay, maybe just another 20 seconds for those that are still taking this down, and then I'll move on to the questions already. Okay, so we start with the very first question here. Let's take a look. Okay, I'll just give you a minute to try. Okay, let's try question 14 together, shall we? All right. So how far does a cyclist travel when its acceleration is negative? Acceleration is negative is referring to the part where it is slowing down. So I'm talking specifically from 30 seconds all the way to 60 seconds. How do I find the distance traveled, guys? Remember, it is area underneath the graph, correct? So the area underneath the graph is the distance the cyclist traveled. So how do we find the area here? You simply take half base times height, right? Area of a triangle. So you take what's your base? Base is from 30 to 60. So a total of 30 seconds. The height here is 8. So what's my answer? That's it, lor. All right, Ken, 120 meters. So to solve this question, firstly, you need to know acceleration is negative when velocity is decreasing. To find distance, you find area underneath the graph. Moving on to the next question. This question is very common. It came out in O levels 2 times in the last 10 years, right? Latest it came out was 2020. So let's take a look at how you can solve this question. Do you all still remember terminal velocity, what we discussed? Terminal velocity means what? The speed is constant, right? Height is distance. For a distant time graph, it means that when we are dealing with distant time graph, the gradient is your velocity. Therefore, when we are dealing with terminal velocity, can you see the gradient here is straight? Right? So if the gradient here is straight, it means that the speed is constant. So what exactly is the terminal velocity? You simply need to find the gradient of this graph here. So for those of you who are more familiar with y1 minus y2 over x1 minus x2, you can do that, okay? Or you can simply take x over y. So I'm specifically using this spot here and this spot here to find my gradient. So what's my decrease in height? It is 3, right? 3 minus 0 if you want it. And what is my time? From 1 seconds to 2.5 seconds, all right? So you can simply take 1 minus 2, that's 1.5, all right? So at the end of the day, if you take 3 divided by 1.5, you'll get 2 meters per second. So you use the gradient here to postulate your velocity. The constant part is your terminal velocity part. Okay, that's for question 17. And moving on to our final question. Okay, pro tip, if you remember your pro tip, go and refer to it now. Okay, so we have 2 objects, same size, same shape, but one is heavier. The heavier object, same or different initial acceleration? They will have the same initial acceleration. Remember, I told you both objects experience the same gravity, right? So same gravity means same initial acceleration, all right? But the heavier object will have higher terminal velocity. Okay, so if there's air resistance, we take gravity minus the friction. I think you're thinking of resultant force, which is something I'll address in the next chapter, okay? But I think you're on the correct track. But take note on question 9, all right? If it appears, I hope you all can score, all right? Just remember, if 2 objects, one is heavier, initial acceleration is the same because gravity is the same, but the heavier object will have higher weight, so the terminal velocity it will reach is higher as well. Okay, if not, we're down to our final chapter, dynamics. Okay, now here there are a few specific things I need to highlight, all right, very quickly. Weight is always acting downwards due to gravity. Tension is always pulling in the direction of your rope. This one is the important one. Your normal reaction force is the force based on the object being placed on a surface. It doesn't really matter whether it's flat or what, but even if it's at an angle, it will always be 90 degrees to the surface. So remember, normal reaction force is always 90 degrees to the surface. Your weight is always vertically down. Gravity is pulling it down. Now, there are a total of 3 Newton's law. For those taking combined physics, you do not need to know the third law. Okay, but let's talk about the first 2 laws first. Now, take note, right? You're not required to memorize Newton's law. But what you'll be tested on is, can you apply Newton's law? So for Newton's first law, I commonly just tell my students to think about, okay, just visualize momentum. You know what's momentum, right? You run, then you suddenly need to stop, right? But your momentum will bring you forward, right? When Usain Bolt run past the finishing line at the 100-meter race, does he just stop there? No, right? That dude just keeps running for a bit more, right? Because of forward momentum. Same thing, if you are not moving, you're at rest, you feel very lethargic to start moving. For example, you haven't started your revision yet for mid-years. Then you want to get started, you're like, wow, sian, I don't want to get started. Why? Because there's a lack of momentum, right? So for something that is at rest, you kind of want to remain at rest. You get what I mean? Like you're lying on bed, then your mother asks you to wake up and go back your room. You kind of just want to lie down there, right? Because you're at rest, you don't want to move. Okay. So that is momentum. It's difficult to get started. But once you get started, it's easy to continue doing so. So this whole idea of Newton's first law is called, you can think of it as just momentum, but at O level, we define it as inertial. Okay. What affects your inertial is the mass of the object. Okay, there are different scenarios where inertial can apply. Unfortunately, I don't have the time to go through all of them today. You just need to know if something is not moving, it doesn't want to start moving. For something that's already moving, it doesn't want to stop. All right, that is at its core what inertial is. For Newton's second law, this is even easier. This is F equals to ma. But today I'm going to teach you a cheat code, okay? Please don't write F equals to ma. I want you to remember Rf equals to ma instead. Why is this important? Now, take note, F here doesn't stand for force. F here stands for resultant force. What is the difference? Force can be anything, right? Just one force. You can have three different forces. Resultant force means I account for all the forces. I plus, minus, subtract, whatever finish already. The result of it is the resultant force. It is the resultant force that's equals to mass times acceleration. Now, how does this apply in the form of a question? Let's quickly take a look at this question 2 here. All right, now, if I don't show you all the answer, right? So if I just zoom in, okay, can I zoom in? Right, if I don't show you all the answer, I just show you all like that. Right? You know what most of you are gonna do? This is the classic. You're like, okay, this is Newton, this is force. This is mass. Wow, I'm a genius. F equals to ma. Confirm one. The first time you do it, this is what you're going to be thinking, right? F, formula, right? Just memorize formula, you'll do well, correct? Then you say, 500. What's my acceleration? Then you take 7500 divided by 500. You tell me acceleration is 15. Sure, I got the correct answer. See, I use formula, I put in the values. Correct or wrong? I mean, of course, the precursor is this is wrong lah. Okay, so why is it wrong? F equals to ma, what? Correct? Wrong. Remember what I told you all to memorize? It is Rf equals to ma. Rf means what? Resultant force. We need to account for all forces acting on the object. So if my object has a mass of 500 kg, you need to remind yourself that there is a weight. How much? W equals to mg, right? G is a value of 10. I have a weight of 5,000 newtons, which means that when I actually go and calculate my resultant force, it is not just the 7500. You need to say that, okay, there's an upward force of 7,500, but there's a downward force of the weight, which is equivalent to 5,000. So when I go and subtract the two, I realize that the result of it, the resultant force, is 2,500. Then I can do my Rf equals to ma to find the acceleration accurately. So what I'm trying to tell you here is simple. Most people are going to be thinking F equals to ma. Wow, shock, I'm done. Please don't think that simply. Remember, you are finding resultant force instead of just using force. If you can keep that in your mind, you'll be able to avoid many, many errors. The two most common calculations to find resultant force will include driving force minus friction and tension minus weight. The question we just did was tension minus weight. Driving force minus friction is more applicable for a car that's driving, right? Driving force by the engine, and there's friction. Friction in the form of friction with the ground. Okay, that's how you will find your resultant force. Then you use the resultant force to take mass and acceleration. Are we clear? So Newton's second law is not as simple as it seems. Remember, resultant force equals to mass times acceleration. And finally, for Newton's third law, this is the basically I push you equals to you push me. Okay, so what I'm trying to say is this. If there's a wall here, you didn't study your physics exam, you decide to go and bang your head on the wall. Please, I'm not suggesting that, but I'm saying hypothetically from a physics POV. Okay, I shouldn't draw this smile. It looks a bit creepy. It looks like the Joker. Okay, let's say that this is you. You're very sad. Okay, you decide to hit your head against the wall. When you bang your head against the wall is also banging itself on your head. Okay, what does this mean? For every action, there's an equal and opposite reaction. If I exert body A exerts a force on body B will exert an equal and opposite force on body A. So when you hit the wall is also hitting you. You know, there's like these jokers in school, right? They like go and like for randomly no particular reason, they just slap you on the back, right? Or for somebody that maybe you give them a high five very hard. But you know when you high five somebody, when your hand hit their hand pain, right? Actually, your hand also pain, right? That's true, right? So actually, when you exert a force on your friend is also exerting a force on you. So when you punch somebody, their face is also punching your hand, something like that. That's all it's saying. You know the classic example in your textbook, the swimmer keep off the wall. So it's not just the swimmer exerts a force on the wall is also exerting a force on the swimmer. So this is what we mean by Newton's third law. I'll show you the question type later on. All right. Other than that, this chapter is pretty straightforward. Free body diagram, vector diagram. Vector you'll learn in math, so we'll address it then. And lastly, you just need to know for friction. Okay, friction, there's useful, nuisance, and reducing friction. I think you can find this in your school notes, so I won't go through this too much. The last thing that I need you to know is that if I'm walking to the right, my feet is dragging backwards, the friction between the shoe and the floor would be in the same direction as my movement. You might feel like, hey, that's a bit weird, right? I'm walking to the right. How is friction in the same direction? You need to remember here we're discussing specifically the friction between your shoe and the floor. So your shoe will be sliding backwards, generating a friction in the opposite direction. This friction allows you to move forward. For those of you who do sports, you will know what I mean, right? Assuming the floor is super slippery and you decide to play like your basketball or like floorball or whatever, you realize it's actually very difficult to change direction and run. Because at the end of the day, how much you can accelerate and run is based on how much friction you're able to generate at the floor. For my badminton players, you'll know, right? When you buy badminton shoes, the grip at the bottom, those are all meant to generate friction. Friction will always be in the same direction as your movement. If there is a car, this is my car wheel, and my car is moving towards the right, which direction is the friction? Friction between the wheel and the floor would be in the same direction as where the car is moving towards, right? That's something that you need to know and establish. Okay, with that being said, let's go through the final 3 questions for forces. Let's take a look at question 1, free body diagram. After this is the giveaway already, okay? Okay, so number 1, when we see weight, I need you all to know weight will always be acting vertically downwards. Normal reaction force will always act 90 degrees to the surface it's on. Lastly, if the box is on this slope, normally which direction will it slide? It will slide down this way, right? Because it slides down the slope. So friction will be in the opposite direction. Okay, so answer here should be C. This is what we mean by free body diagram. Remember, normal is 90 degrees to the surface. Next, let's take a look at this question. How to do, right? So the most important thing I told you all that when we're discussing is to remember this chapter is not force. It is always about resultant force. In this case, your resultant force is your driving force minus your friction. So this is a car. The car engine is generating a driving force of 2,500 Newton. But the car will also be experiencing friction with the floor. So your resultant force here is 2,500 Newton minus friction. Meanwhile, they told us that your acceleration is 2. So if you really went ahead to do some calculations, 800 multiplied by 2, my resultant force was 1,600 Newtons. So the simple question is, how much is my friction? Get it? 900. So what I'm emphasizing here, doubly hard, is this resultant force, driving force minus friction, or tension minus weight. Just remember, F equals to MA is not F equals to MA. It's RF equals to MA. If you remember that, you'll be fine. Okay? So this is for question 14. And finally, for question 10, if you see a phrasing that goes like that, force on water due to propeller, force on propeller due to water, this is what we call an action-reaction pair. Water exerts a force on propeller. Propeller exerts a force on water. This is Newton's what law? This is Newton's third law, correct? So water exerts force on propeller, propeller exerts force on Newton. It will be equal and opposite. So if the force here exerted is 2000, the force for the action-reaction pair would also be 2000. You can ignore the resistive force. Resistive force will only be needed if you're calculating resultant force. Okay, is that clear? All right, so here we are discussing Newton's third law, and I think what's really important is that you need to know that when we are doing such calculations, it's very important for you to establish which law is discussing. Question 10, not needed for combined science because it's Newton's third law. But for the first two questions, yes, that's Newton's first and second law. Okay, and with that, I think we have come to the end for the revision. Please stay around because we have something exciting at the end. So in summary, what have we done? In a short 1.5 hour span, we did 2 chapters in chem and 2 chapters in physics. I admit I wasn't able to go fully in depth, but I covered the most important parts as best as we can. Other than going through the concepts, we also did some commonly tested questions. This is to ensure that you'll be better prepared for your exam or test or WA, whatever. But you need to know how to apply, right? So you realize that some of the practices were quite helpful in terms of getting you up to speed with that. Now, whatever content you saw today was from the curated notes itself. So that is the soft copy. Of course, there's just 1 or 2 chapters inside. Of course, if you're interested in getting your own copy, you can just scan the QR code and purchase it. The link is also available on our website and whatever lah, okay? But only purchase it if you feel you need it. If your school notes is good enough, then don't have to, right? But if you like the way the notes are structured, you know, because the keywords are all bolded and stuff with work examples and stuff, you can consider, but this is really up to you, okay? If you want to supercharge your revision, this might be a consideration. Now, on to the highlight for today, okay? So we're gonna be having a simple Kahoot quiz, all right? All the questions in the Kahoot are all things that we have done before, earlier in today's revision. The winner will walk away with a copy of the curated notes, okay? As simple as that, okay? So we're gonna shift over to the Kahoot now. All right, I'm sorry for my Chem Bio students, but the Kahoot quiz was designed based on Chem plus physics questions, okay? So my Chem physics students, you have a better shot, but for my Bio students, please don't feel sad. You still stand a chance to win it, assuming you know how to do some of those questions. Okay, so I'll just start. You'll know how to join, right? Okay, please label your name properly, because I need to identify the winner after this. Okay, I'll start in 2 minutes, so please join soon. I say already, there's only one winner. Winner wins the curated notes, okay? But after this, I got something special for everyone as well, so you can stay around even if you're not playing your Kahoot. There's a special thing that I wanted to share after Kahoot. Okay, Kahoot will probably take around like 5-10 minutes. Hey, who will the one winner be? Why got insect one? How you even type the insect in? Oh my god, that's amazing. Okay, I'll start in 1 more minute. Give you all some preparation first. For those of you who have a periodic table nearby, please have your periodic table ready. Have your calculator ready as well. Okay, most questions would be 30 seconds. There are some bonus questions that are a bit longer because it requires more calculation. Okay, I'm starting in 10 seconds. Nicole getting in just in time. Okay, but I hope today's session was helpful. I really tried my best to squeeze as much as I can already. But I'm sorry I'm not able to answer some of your questions. Okay, 10 more seconds. Okay, 5, 4, 3, 2, and we shall begin. You know, I need to click fast, more point. Newton's third law. I push you, you push me. Force on water due to propeller, force on propeller due to water. Alamak, why so many of you choose A? Not resultant force. This is asking about Newton's third law. Okay, so very straightforward. Just I push you, you push me. Okay, so the value will be the same. Wah, jalan. Okay, so what you want to be thinking of is which one would form an ion with charge 2 minus. If you go back to your periodic table, if you label at the top, right, you'll get different values, right? Which group has a charge of 2 minus? Group 6, correct? Okay, so for those of you who managed to find that out, is because you were able to go to your periodic table quickly, identify that 16 protons means it's referring to sulfur. Sulfur is in group 6. Group 6 will have a charge of 2 minus. Okay, this one was quite difficult, but I hope some of you still got it right. Definition for isotopes. Same number or what? Different number or what? This one everybody should be able to answer, right? We went through this question in class too, guys. Wow, still got people get it wrong. Guys, same number of proton, different number of neutron. Okay, next question, let's go. High melting point does not conduct electricity in solid state, but conducts electricity in molten state. Ooh, which structure are we discussing? Which one can conduct electricity in molten and aqueous state only? Good, huh? Okay, so you need to know we are referring to your giant ionic lattice structure. Okay, we have new people moving up the ranking. Very exciting. How do metals conduct electricity? Mobile charge carrier, right? What exactly is your mobile charge carrier? Right. We say ionic compounds can conduct electricity because of free moving ions. Metals, eh? How do metals conduct electricity? Free moving what? C of delocalized. Electrons, your positive charge cannot move. Okay, it's your electrons that are transporting that electricity for you. Wow, how you answer so fast? What the hell? Is it your don't take physics, so anyhow click quickly? Hopefully you can get the correct answer. How do we find distance for a velocity time graph? Distance, area underneath graph. Okay, so you can find the area of the triangle followed by the rectangle. Okay, don't worry, there's a time chance to turn the tables later. Covalent, is between what and what? Metal, non-metal? That's ionic. Covalent means non-metal and non-metal. So which pair would form a covalent molecule? Yeah, I think most of you managed to get this right. Just need to remember we're dealing with non-metal covalent bonds. Right, Newton's first law, what do we call that? Right, momentum. I don't want to move, but once I start moving, I don't want to stop, right? Inertia, very good. Okay, take note, for the last two questions are heavy calculation questions. You're given more time, but the weightage of the points is doubled. So time for those who are lagging behind, last chance to catch up. For those who are still struggling, think about resultant force, mass and weight and tension, resultant force. Okay, so the trick here is that it's actually the exact same question we went through earlier in the notes. It is about taking the tension minus the weight to find resultant force, then RF equals to ME. We went through this question just now. Right, RF equals to MA. Then you need to know resultant force is driving force minus friction. So were you paying attention? If not, can do the question quite easily. Okay, let's see who the winner is. Okay, don't worry, there's still something else later, so don't run away just yet. Wow, got people get 10 out of 10. What, 10,000 scores, yeah? Hey, congrats. Healer. Okay, so we'll please contact me later with the details and I'll send you a set of the curated notes. All right. Okay, for the rest, please don't be too sad. I have something else to share with you guys before we go off today. So I hope you all enjoyed the revision thus far. Now, I just wanted to share something very quickly. So as I mentioned, right, most of my classes are Sec 4s, all right? But for those of you who feel like, okay, you like the way I teach and stuff, and you're wondering how will it work, okay, just take note that I'm actually opening up this priority list, all right, for anybody that's keen to join my group tuition. But take note, right, the tuition will not start up till November this year. So what I have is a year-long program, which means I'll be guiding you and working with you week in, week out on a 12-month basis to prepare you up to your Sec 3 holiday, up to your O-level itself. So what will happen is that every week I'll be working with you. You'll get the curated notes for free. Every week you get a set of worksheets and you also get exam papers to practice. Now, if you choose to pre-register, it doesn't mean you have to join the tuition. It just means that when it comes to September and October, I'll be reaching out to you first and you'll gain priority in terms of joining the group tuition. So every year I have a limited capacity because I only can have that number of classes. and the number of students per class is fixed. So if you are keen to join, you are interested, you can pre-register. It's very easy, just leaving your contact details. Furthermore, inside the registration, there's an option for you to opt in to the email list. Should you want to join the email list, from time to time, I'll be sending out special materials and learning resources. So this one is quite exclusive. Only if you opt in there, I'll be sending it to you. All right. In terms of the timeline, in November to December, should you join the group tuition, we'll be recapping your older Sec 3 topics. Very in-depth. Every week we'll be talking about like your MOE concept and stuff, things that you learn in Sec 3. In January to April, that's when we'll start focusing on your Sec 4 topics, usually the more difficult ones. In May to June, we'll be embarking on this thing, what I call the thematic revision, which means I'll be helping you join the dots and link similar chapters together and telling you about hybrid question types. In July and August, we'll be purely focusing on your Sec 4 prelim exam preparation before moving on to O-level preparation. So this is a year-long program. It's very well structured. I've done it multiple times, and usually the results are quite favorable. So some of my students, they were really just to share, like last year itself, some of them actually were top in school. So they didn't even need to wait for their O-level results because they already knew their results based on what was flashed on the screen itself. So these are, of course, the best cases. There are many cases that they did really well with many improvements as well. Okay, so the QR code is already here. If you want to, you can pre-register. Assuming you're registering with your friend, you can also indicate the name so I know that you guys will want to be in the same class itself. All right, so the subjects available will include pure chem, pure physics, or combined chem and physics. All right, so if you are keen, just scan the code, register now. Doesn't mean you have to join a group tuition. It just means I'll be contacting you as a priority list should you be interested. Okay, for each class, the class size is around 6 to 8, depending on the classroom itself that we're using. Don't be too worried right now. This is just to indicate your interest. Okay, and to finish up, for those that enjoyed the mid-year exam revision, do leave us a kind Google review. I think that would be really nice. Okay. For the charges itself, usually I'll collect fees at the end of the month. Is at a very reasonable rate. It's just $45 an hour. So for a weekly 2-hour lesson. Okay, it's pretty much market rate or slightly lower because you'll get all the materials for free. So you get curated notes, you get exam papers. Every week you get a new worksheet as well. Okay, so I usually only take in Sec 4s in September. I mean, Sec 3 is going to Sec 4, right? And I usually, right now, I have around 10 to 11 different classes. So they are all Sec 4s. So I know some of you approached me like Sec 3 can join my classes. I honestly don't have the slot because I want to focus on the most urgent batch, right? Which is those that are heading for exams straight away. Okay, so if you're keen to work with me, you can sign up first. Once I know you're interested, I'll reach out to you again in September to confirm. Sec 5 definitely, because Sec 5 you would fall under the O-level track as well, which means I can work with you definitely, depending on the subject you're taking, but usually it will be combined. Okay, if not, I hope that most of you here today, you had a good revision. All the best for your mid-years. I hope the session was helpful. I'll be uploading this as soon as I can, probably tomorrow or the day after. If you have further questions, feel free to check with me directly on Telegram or whatsoever. Okay, I hope that this was helpful. Yes, I'll be the one teaching the chemistry and physics crash courses. Those I think are a little bit more for Sec 4s heading to O-levels. But yes, it's me. It's me. If it's chemistry and physics, it's me, guys. Okay, so do sign up. Those that are joining the priority list, just let me share with you what you'll be getting. There's this mid-year exam cheat sheet that I've prepared. All right. You'll be getting a copy of this via email if you opt into the email list. So these are just some of the materials you will get from time to time. So these are more for my potential students to be, like you all want to join a group tuition, right? Right now I cannot teach you, but at least I can give you some resources from time to time. So that is why there's an email list here. Okay, don't be too worried if you feel like I just want to indicate interest, but I might not join at the end. It's perfectly fine because depending on whether the timing and everything works out. Okay, but usually by the time it hits December, more or less most of my classes are filled. So there's a limit to how much I can take. So if you want to, pre-registering will give you the priority. That's all. Okay, anybody with any questions? I'll be around for the next 2 to 3 minutes. You can let me know if you have any questions. Okay. No problem. Thank you for attending too. I hope you all enjoyed the session and found it useful. Okay, very compact, 1.5 hours. Okay, go and have your dinner, guys. And those breaking fast, I hope you all can break fast soon. I do not know what the exact timing is, but yes. Yes, the tuitions will be physical. Most of them, most of the classes are physical lessons. Thank you. Bye bye. Feel like some live streamer now like that. Okay, Healer, right? I don't really know how to pronounce your name, but Healer, the winner of the giveaway, right? Can you just go on Telegram and text me? Then you just need to send me your name and your address. I'll send you the notes. Sec 4s, yes, I'm still accepting classes, but subjected to availability. A lot of my classes are already full. But you just text me. You know how to find me on Telegram, right? I'm literally like the admin of the channel or whatever. Just find a way to contact me for the Sec 4 classes. Okay, Helen, if not, you can also text me on WhatsApp. That's fine too. Yeah, you go onto the website, you go and click my name. There's a WhatsApp option. You can just WhatsApp me straight away. Okay, I can send you my number now anyway. So you just WhatsApp me. I just need your name and address, and then I'll send you your notes. Okay. Okay, if not, I'll be logging off here. Ryan, your question, how do you know if it's increasing or decreasing rate, right? You look at the gradient. If it's sloping upwards, right, like curve up, that is increasing. Decreasing means it's curving down. That means it's slowing down. Terminal velocity is decreasing acceleration. Okay? All right, people, that's it. And I'll see y'all again when I see you again